Welcome to another teardown video. This time it's a multimeter GDM-8246 from instek. It is a dual display digital multimeter. So what is that? Yeah, I don't know if we can see this if we put this in this light here. So I think we got 4 digits, some small ones, and then 5 digits, some bigger ones. And it got RS232. The GBIB is not an option, but it can do 20 amps. So maybe we can read voltage and current at the same time or something like that. Why would we have a dual display? And voltage and current means watts at the same time or something. I don't know. AC plus DC. So maybe that is what it will do. I'm going to experiment a little bit with this in a second. Let's. Yeah, it's all yellow. This is very typical for instek instruments when they are between 10, 15, 20 years old. They all look really yellow and not so appealing anymore. So I think there's a rear plate where you can change for the GPIP interface, but this one is RS232. Voltage is 230, so that is fine. All right, let's plug it in and see if it works. I just plugged in mains and we got 0 usage. So this means this switch is disconnecting mains. Ooh. 8 point. Okay, it goes down to 7 watts. So there's a lot of flicker. Okay, so what is that? Oh, auto range DC. So now we're out of auto range. How do we change the different ranges? Maybe that. Okay, so just move the dot. Ah, that is actually pretty cool. Whoa. How many thousand volts can this do? DC 1200. Wow, nice. I actually needed something that could do more than 1000. Oh, I hope one day I would get some that can do more than 1200, but that is pretty good. Okay, so how is it going to show more than? Okay, it can 4 digits in this range. So that is DC voltage, AC voltage, yep, and the same. Wow, microvolts of resolution. Overload, okay, auto, go out of kilo. Okay, this can't do 4 wire ohms, so this is only 2 wire ohm. I can't wait to play with that. We got a relative, we got diode tester as well. That is nice. Capacitor tester. Hertz ripple. And the AC and DC amps. No relays. Yes. See? Now it's doing a lot of. Okay, so the flickering is. Why are you doing that? But I really don't see this flickering with my eyes, so. See? It is only a thing on the video, so. Please don't feel bad about this meter because of the video, because it looks really nice and stable in reality. Okay, let's connect something and I'll get back. This is the finest range in manual mode. Yeah, so this is the finest range. So we've got 0.1 millivolt of resolution here per digit. So, but this is of course resolution, not accuracy. So I adjusted the voltage to almost 123. So this is the kind of voltage that I adjusted to. This one got one more digit, so it should be 1227. So it is really close. So I think this is a 4.5 digit meter. And see if we go into auto range and then crank up the voltage in, let's take 1 volt steps. So 3, and we're still in this range, and also 4. But see what happens if I give it 5. It goes to overload and then it changes to the next range. And of course this is also 5.125. 5. So again here I got one more digit, but it is really close. I am very happy, and it's really good readable digits. So let's see the next range. When is that going to change? Probably at 50, right? Just like the other one did. Let me see. So 32,019, and I got 32,009. So that is really great. I didn't figure out how to do the dual display yet. Do I really need to find the manual for that? So I went into DC amps, and in the like that, and in the 2 amp connector, it went into microamps. So I guess this is the finest range of its. Let's go to auto. Yeah, this is the finest range for its currents, and this just reveal a little bit of leak current in my load, and it is okay. There's a little bug here when it comes to readout. See? Now it's okay. How can I? Okay, there's maybe. Let me see. Oh, if I do like this, and I can prove that the current is still going through this unit, because I can read the same microamps somewhere else. I got 32 volts going through this, and I still got the current, and it is connected via a load, which is turned off. So that is the leakage I got, and there's some loose connections in this when it comes to really low currents, so that I need to solve. But let's turn on 10 milliamps and see what happens if I go into auto range. Click. Let's see how. I think I heard a relay. So it goes to 10 milliamps, and I know that the load is not very accurate at 10 milliamps, so this is very normal. 10.2 something, and I also read 10.2 something, so I actually think it's very accurate even to the 4th digit. So that was 10 milliamps. Let's crank it up a little. Let's be a little bit more friendly. Okay, so let's try with 100 milliamps. We got 100 milliamps. think this is reading a lot like the same. Let's see a little bit about resolution. If I give it 110, yeah, we got 110.2, 110.2. What happens if we go up 100? Oh, there's a full relays. So that means 400, and we are milliamps. I think it's a little bit difficult to read those small letters here, but I don't know. You get the point. So that is 410.37, it says. And I actually got the same kind of digits here. You see? That is really, really cool. What if I go up 500? Yes, click, click, relay, 510. And then, okay, I got one more digit. So yeah, current is great. Let's see if we can actually make an accurate 2 amps. So that is about 2 amps. How about we just see if I can actually do it? Yes, I could. So this is what this meter reads. This is what I think it is. At the cost us real cheap, I think this is amazing. Hopefully I can show you this. So this is the connectivity mode. See? And then so the beep comes a little bit delayed. It's not a huge delay. See? I'm just able to prove it is there, but anyway. So an ohm. Aha, so they calibrated the 0 with some sort of wires. Is this really 2 digits? If this is really true, I can't believe it. Let me see if I can measure some really, really low milliohms. So this is 0.1 ohm that I connected, and I didn't do a lot more about it. So it's actually almost measuring this resistor. So, but what I think we need to do to measure really, really low value resistors, how about I just take the 2 hooks like this, and how about I use this relative feature, shift relative. I think now I have zeroed my meter, including the cables and the hooks and everything, right? So what if I measure my 0.1 now? I can measure a 0.1 resistor with 1 digit in a 2-wire setup. That is not bad at all. I'm actually I'm really impressed. So that is 10 milliohms. Wow. Oh, I figure out how to use the dual display. The manual don't say a word about how to operate the dual display, and it is only in some combinations where it makes sense or where it can be used. But of course it can measure AC voltage, and then you can by shift hertz ripple, and then you get the frequency. So this is 1 volt RMS, 1 kilohertz, or at least very close. So that means it really does work, right? So let's see what kind of frequency, or what kind of, So that was 10 kilohertz. And of course it reads 10 kilohertz as well, and still this 1 volt. And let's crank up the frequencies until we see a voltage drop. So that was 100 kilohertz. Really? Wow, look at that. Okay, so now they're 200 kilohertz. Okay, so that means maximum frequency readout is 200 kilohertz, and so that is probably what it's specified for in the AC voltage as well. But as you see now, this is 300 kilohertz, and it still reads out pretty fine. Let me give it. Okay, that is 900 kilohertz. That is 1 megahertz for half the readout. So that is very, very impressive, the range that this can handle. Let's see if there's any. So that is 100 kilohertz and 1, yeah. 100 kilohertz and 1. See? And I don't know, if my other sexy display can do that. If I go to, yeah, okay, it could do that, but it probably can't do both of them at the same time. So I need to sit here and single dual, la 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 la. Maybe I can do this, dual this, and not that. I don't know. Whatever. Shift. Frequency. Let's see. Yeah, where's the frequency? Duh. Yeah. Look at that. It really worked. So this new modern funky stuff can also do what we have been able to do the last 20 years for almost no money. Fantastic. But how about we see what is inside? Time for teardown. I found only one screw here, and it didn't come apart at all. And I was looking, maybe there was a hidden screw under some stuff, but there's not. It seems like you need to press one side really hard down and then the other one out, and then do the wiggly. If you take a screwdriver here and try to use force to open it, you're gonna add a lot of nasty, ugly marks on this plastic. So that was actually a little bit difficult. I am in, but I don't understand the handles. At the end of the handles we got those funny metal things, and they seem to do absolutely nothing. I don't get that. So we'll see. I think this is the main professor doing all the fancy things. And that was our beautiful beeper. We got the power supply, nice and linear, the good old style. Mains transformator. That will be the serial port. It's the same PCB that also support the GPIB or parallel, or what kind of interface is that? I think we need to have a little look in here. What is that? And they have been so nice and friendly to write down all the different calibrations. And the 20 amp current range. There'll be some other current sensors there. Some relays. The LED display is nicely multiplexed by this processor. There will probably be some line driver IC somewhere, maybe underneath the PCB. But I think we should open it a little bit more. But so far it's looking really, really great and perfect. This is how you do it. It was like a reversed Tetris game. Just to figure out how to open this thing. But anyway, in this I found something really cool. This is the serial interface, and obviously this will go to computers and such, so the possibility for getting also some nasty stuff back in here is really high, right? So what they've done is, this is the connector for the serial port, and the power supply for the serial port is a separate isolated winding, and this is a little power supply for the serial port, and look at that. Optical interface for the serial unit. Isn't that just nice? So there's not any bad stuff coming in here. I think this is fantastic. And underneath this piece of plastic is where they hit the last screw. So now I should be able to pull this up. There's a screw here and a screw here. I don't think I need to pull up those two screws. I took out one of them, but I don't need to do that, I guess. So this is the bottom side of the case, and of course there's metal and this springy contact. I think this is located where this one is. I think this is a little bit special designed. Maybe they had the idea there was going to be a screw or something, but this is how they did it. So this is the bottom side of the board, and of course we see the CPU is multiplexing the display with all those signals. Also got some high impedance or low leakage stuff where they're milling out, or high current stuff they want to go in the right directions. Clearly this PCB layout is done with a lot of considerations for details where it's important. You can also see the low leakage here around some special pads and such. Really good done. And of course this is important. So I took off this shield, and now we can easier see what is inside. Here we got the analog front end for the whole digital multimeter. This one can use external reference, and it actually uses an LM399, and that is amazing. Wow, in a 4.5 digit meter you see a real LM399. That is amazing. I am super happy about that. And that maybe explains why this one is so fantastic. I took off the label, and this is indeed an 8-bit microcontroller. It's an 8052 style microcontroller. And we got all the relays for the different ranges of voltage currents and all that stuff. I think what we see here is the voltage ranges, and this is of course this for all the different voltage divisions, and we will of course have capacitors here, so it's super good for AC. Up here we got some really nice and special circuits, and I think this is the AC RMS, or it could also be, yeah, so far this is what I think it is. And the power supply far away from everything. But I don't like the way the two regulators here are mounted directly up against the capacitors. That is not so good. So probably I need to check those capacitors. Are they still any good? Yeah, I think this is what I wanted to show you guys about this super great voltmeter. So if you can get one of these digital multimeters for cheaps, I definitely recommend it. Just because of the reference, there's hope. Or I don't know really how temperature dependent or how stable all the voltage dividers is. So I'm going to play a little bit with calibrations and such, and see if I can get this really nice and stable.